Hello, this is the syllabus video for the System Administration and Cloud course in cybersecurity. This is the first time that this course has been taught, so we kind of have a blank canvas here, and I'll let you know how this is going to work. First, we will have Monday, Wednesday, Friday meetings. These are at 4:40 to 5:30 p.m. And like my other course, the big data course, these are going to be primarily like stand-up meetings. I don't intend to do a lot of lecturing in these meetings. So this is more kind of like an office hours kind of situation, but for the course specifically. See where you are, see what your issues are. You can ask me to go through something again, or fix issues that you're having. And it's good to kind of all see what everybody's working on so that we all learn together. Since we don't have a classroom, obviously there's not many ways to get a community for this course, and so we'll use these meetings as a way to come together. I'm going to make videos for this course, and these will be instead of like a big course website or instead of a book. We're going to use some cloud providers, so there's going to be a lot of documentation from them and the other open source tools that we're going to use, so there's really no reason for me to reproduce that kind of material. And I do want you to be aware of the official documentation sources, because that's what you're going to have when you go out there and have to do this stuff in a job situation. Assignments. Really, I don't have a lot to say about assignments yet, because they're all going to be a little bit different from each other since this is a complex course. So that's kind of the one common element of this course, and makes it quite a bit different than a lot of other courses. We're going to be using a lot of different tools and services here. It's not like we can just say all the assignments are going to be some code and you submit the code and I run the code or anything like that. It's not going to work that way, because what you're going to be asked to do in some cases is make a functional site in the cloud. You're going to have to click around Amazon's interface to configure things. And so my checking that you did that will be a matter of going to your cloud service and ensuring it's functioning, that the domain is correct and DNS is correct, that there's appears to be caching enabled and things like that. So it's going to be a little bit difficult to know ahead of time what every assignment's going to look like as far as what you produce as an artifact. So ultimately, check Blackboard for each assignment. It will not always be code, or at least not solely code. There's probably going to be some code in every case, but exams. This is going to be done like I'm going to do in the big data course. This is new this time, and the approach I'm using, we're going to do these, what do they call them? Live coding kind of sessions like you would see in an interview. So in an interview for a job, you're often going to be asked to produce a solution to a problem right in front of them. Like they're going to look at your screen, you're going to share a screen, or if you're doing it in person at some point, you're going to be doing it on a whiteboard. So this is, we're going to do that in this course because it's a way for you to practice that sort of kind of intense situation of someone watching you code. So naturally, you're only going to really know, you're going to only be able to demonstrate proficiency if you know what you're doing. And in this kind of course, again, it's not always about code. So I may be watching you configure something on Amazon, for example. So these are going to be live coding style, one-on-one, 1 hour sessions, like interviews for software engineers. There would be 2 of these, one kind of middle of the semester and one in finals week. So this, you're not going to have written tests, you're not going to have Blackboard tests. It's going to be these sessions, and it's one-on-one, so it'll take the whole week. I'll have to do each person separately. So that results in grading as follows. Exam 1, 30%. Exam 2, sorry. assignments, and then attendance at our Monday, Wednesday, Friday will be 10%. Now we'll not necessarily always use the full 50 minutes Monday, Wednesday, Friday. We'll see how it goes. I don't feel the need to like pad the time, like we're in a classroom. So if we find that we're still being efficient and meeting less time or fewer days, then we can do that. But we'll see how it goes. So what will we cover? Well, again, this is the first time this has been taught, so that kind of tells us we should look at what the catalog says about it. And the catalog says that it should be Windows Server and Linux, cloud environments, and virtualization and containerization, and cloud computing providers like Amazon or Google, and Kubernetes. So we're going to incorporate all that. It's primarily going to be, the majority is going to be Linux focused, because not only is that the kind of majority of cloud computing, but it's cheaper, and it's just what most tools are going to use. So we're going to also focus on Amazon Web Services. There's really not much benefit to using IBM Service, Google Service, Amazon, Microsoft. We don't need to use all of those to get the idea of what cloud computing is about. And I have most experience with Amazon, so we're going to use that. It's also the dominant one, so that's where most people are. And then for the Windows Server stuff, we're going to use Azure from Microsoft. In both cases, there are free credits for educational for students. And I've already emailed you about the Amazon one. There's a similar thing for Azure once we get to that point. Of course, we're going to emphasize security, cybersecurity course, but that's not the only reason we're emphasizing security. It's just once you start putting stuff on the cloud or on the internet generally, you better know how to protect that stuff, because often by default, you're going to have databases and other services be open to the world unless you do something about it. So Amazon has all the tools you need to make a super secure installation, even encrypting data at rest and transmitted or in motion. So you can have everything encrypted and everything super secure, but it's hard to set up. And you can make mistakes like accidentally pushing your keys for Amazon Web Services to your GitHub profile or repository. And if it's public, you're going to find that a bot is going to discover it and then go access your machines in the cloud and put Bitcoin miners or whatever in your on your account. So we're going to have to do some work to make everything secure. So we're going to do Linux servers, Windows servers, Active Directory, and emphasize security. And under the category of Linux servers, we're going to do several things. Virtualization. This would be known as EC2 in Amazon. We're going to do containers, which is Docker, and we're going to do orchestration. I'll say orchestration, Kubernetes, or CloudFormation at Amazon. The order we're going to do all this, the way we get to all these topics is as follows. We're going to start with a very simple Python server that runs on a regular Linux machine. So the old way of doing things. We're going to use delin and write Python web app for the delin server. That way we have a goal. Our goal is going to be to put this thing now into the cloud. So it'll be a little web app that like keeps track of your notes or something. And this would be like you'd find in an early web app class, like a web app class from years ago, or the end of my database class, for example, made a little web app. with Python. Then we're going to push it into the cloud in the simplest way, which is to use a virtualization, a Linux machine under EC2. So that's not super exciting because the only difference then is, Amazon's managing that server, so they keep track of the hard drive and whatever, and where it is in the world, on which server it's actually running on, virtualized. I guess it's kind of the same for you because Delin is somewhere else as well. It's an LBC in the basement, but technically we're in the cloud now if we go to EC2, but otherwise you're still having to configure the whole thing. You're still the root user on Linux. You got to install the packages and so forth. We'll add some other AWS Amazon services such as DynamoDB and S3. So DynamoDB is a NoSQL database, key value kind of database that we can use like to store the notes in the web app. If the web app is keeping track of your notes, you can push them in the DynamoDB. And S3 would be for like static files, like the CSS style sheets or the HTML for the page or images and things like that. But at least then we're starting to connect with other cloud services. Then we'll automate configuration with Ansible. So this is still a technique that's done when you do need to configure like a whole server or a bunch of servers and have it be automated. So Ansible is starting to get into this territory where you can define what the result server needs to have, like it needs to have these packages and these users and so forth. And then you tell it to go and it installs everything for you. So you could tell it to go on 100 servers and it would install everything on all those servers. So Ansible is starting to automate configuration. But we can go further in the cloud. We can kind of start to get away from EC2 where we're managing an entire Linux server on our own. Even if we have Ansible, it's kind of still our server, like we own the whole thing, even though it's virtualized. You can actually get raw or metal from Amazon. You could pay enough to own a machine in their data center, but we have no need to do that. So we're going to start at EC2, not go all the way to the metal. And then we're going to containerize. So we'll put it into Docker containers, and that will ease our configuration issues. We'll configure Docker or container to have all the bits it needs to run our app, and then you can push that container wherever you need it to go and scale it quickly by duplicating it. So that starts to take away some of the pain of running a whole Linux machine all the time, 24/7, and keeping track of its updates and all that stuff. The container will just have our app and the libraries it needs. And again, it will connect to DynamoDB and S3 for the data and the files. And so we're starting to make our app much more narrow in its separation of concerns. It's only going to do the kind of the one thing of connect, show you the website and put the data somewhere. And we're using other services for the other parts. Then we'll go further and then we'll configure the containers with Kubernetes. So we can define more complex arrangements and connections between containers and really kind of orchestrate a very large set of interactions and use something like CloudFormation to even say, go create this DynamoDB database with these tables, go set up this S3 bucket, launch my app in this container, have them know about each other. So you can kind of configure the entire, everything we've done up to this point in the class, basically, except writing the Python app itself. All the other setup you can define as actually what's called CloudFormation scripts for Amazon. Then we'll go serverless, so that, oops, that's Vim for you. so that the various features of our app, we can actually start to separate those into distinct functions, and every function of our app will be a separate file, and we'll upload it as a Lambda function. So Lambda functions are like single functions of code in Python, JavaScript, or whatever that will activate. They'll actually start a virtual machine real fast, activate and respond to this request. So like when you click a button on your web app, it will submit that as a post request. The Lambda function will wake up for just that task, talk to Dynamo or whatever it needs to do, and then disappear again. So really breaking apart the app. And in that case, since all the functions are separate, there's really no server anymore. There's nothing running all the time. It's all just going to wake up when somebody does something, and it's at the kind of micro level. It only wakes up for milliseconds just for that single function. So and then the website itself will be sitting in S3 and just a static set of HTML and JavaScript files. So that's as far as we'll go on Amazon, and then we'll do Windows Server VM through Azure, configure Active Directory, and Windows Server principles. So that's the rundown. I understand why, I was part of it, creating the course to have both Windows and Linux, and there are some things that we could do that would cross both, but I think we have a pretty clear story of advancing one idea to its logical conclusion with this Python app that we ultimately make serverless, but we do need to address some Windows Server stuff, so we'll put that at the end. But unfortunately, I can't see a direct connection with the rest of the workflow, the rest of the process. So this course sort of has two personalities, but it's important experience to have.